All right, next one, I'm delighted to introduce you to Evan Miyazono. For those of you who may not know him yet, he's been a really fantastic collaborator over the years. First, when you were still at Protocol Labs, and recently, I think you've really found your calling with really Atlas and trying to figure out how we can do many of the things that we said we do in theory in practice fast as experiments.
That's definitely the hope. Thank you, Allison. So I have a lot of slides, and I'm probably going to be talking very quickly, so apologies in advance for that, or you're welcome if you're one of those people who listens to talks on 2.5x generally, like me. This is about compliance and oversight. I'm like specifically mostly thinking about AI, but I'd encourage you to think about how this could look generally. And as Allison said, I run this nonprofit called Atlas Computing for about the last year or so. General structure of this brief talk is talking about motivating specifications for AI behavior and then some of the progress that we've been making. And I'll start by pointing out that if you want to trust a system that has been built, you can either trust the individual components of that system. Some of them might be black boxes that you trust very innately, or you can trust the apparatus that you have constructed around that system that could give you trust in the global behavior of that system. We don't have nuclear power plants because we make uranium safe. We have nuclear power plants because we have systems around the uranium that makes it sufficiently safe to meet our expectations. And this isn't just something for engineered systems. This also works for social systems. You can put values into your child, or you can childproof your house, or put them in a crib and do things like that to make them safe. And one risk of taking the former approach of trying to have a trustworthy black box is that the way we currently do this is by throwing huge amounts of value-laden examples at them. And what you end up with is a system that is a vector for ideology, I will claim. And so if you come across a group of people that have a differing ideology, then you might consider their success in this to be an existential risk, even if it is safe by your standards. And you end up with people talking very seriously about nationalizing AI efforts because of this risk. The alternative to this is to take a path that looks much more like the second category, having confidence in the structure around the system. And just to give a general sense of a place where I think even with trustworthy AI black box systems, there will still be a problem. I'd like to highlight what I'm calling the review crisis. I think this is already bad now, and it's primed to get much, much worse. Humans can generate roughly 150 tokens per minute. The fun fact is that this is pretty language agnostic. GPT-4o costs about, last I checked, $15 per million tokens of output, which means that if you want to match a human output in terms of quantity, that's about 10 cents an hour. So if you imagine everyone in the world who is making things now, who were paying people and are soon paying AI systems, they're generating a few orders of magnitude more stuff in a world with general intelligent AI systems. But you can't really scale the review of those things. You either can review increasingly complicated, sophisticated AI outputs, or you can abdicate review and just put it into the world. There are people who talk about letting this review be done by markets or done by profitability, and I think that that gets very worrisome very quickly. And so what I advise is, instead of taking this current architecture where we talk about say, expressing your intent to an AI system, getting a solution generated, reviewing that, and then iterating on this, I think we should take an approach that looks much more like how organizations interface with each other, or people deal with the rest of society in a lower trust environment, where if your company wants something from another company, you generate a set of specifications. You pass along this requirements doc, and they go and develop something, and they give you some amount of confidence that the developed solution meets your expectations for the requirements. And there's some amount of validation on the front half to make sure you've expressed what you want, and some amount of verification on the back half to ensure that what has been built is the thing that you wanted them to build. And I think that, one, this is very nice from a socio-technical perspective, in that this technology matches how we set rules for other people. We have deliberative bodies that come together and set laws, and those laws are applied as very much requirements. Constitutional AI fits this, the difference being constitutional AI kind of has a trusted AI system as adjudicator doing evaluation, whereas what I'm proposing is something where the requirements are more objective and formalized. And if you compare this to what alignment looks like as a solution to trust, that looks much more like it mirrors the political structure of a totalitarian state, where you have some small number or one person who says, these are my values, this is what good is, I'm going to put that in the system. If you solve technical alignment tomorrow, I think figuring out what to do with a box that you could put a person in and they spend 80 hours in it and they come out with an LLM that's aligned with them, figuring out what to do with that is a really hard question if you want something that feels legitimate to humanity. Just to the extent that individual values differ, and even my values today differ from my values of what I want from myself in maybe 5 years. Another conviction I have is that I claim this is the future of software engineering. I think that people are not going to be writing documentation and the beginnings of lines of code and get code auto-completed for them. I think they'll be writing specifications which are more succinct descriptions of what they want to have, and AI system, well, at some point in the near future, we'll have companies that will work off of specs and do auditing or do engineering, but soon we will automate that half of this, and you will have AI systems that do development from requirements. A brief aside, very quickly, if you go and ask a lot of engineers in companies, do you want something like formal verification, which is what this process generally looks like for formal specs. Do you want formal verification for security and stability? And they'll respond with, it's stable enough, it's secure enough. We write good code, can you make compliance easier? And that is not abdicating the review. That is not, I would say, the review crisis in action. That is revealing where critical review of systems that are significant to society is occurring. And so for the spec-driven AI paradigm, you need spec generation, you need the ability to generate code, and you need the ability to generate proofs from these with AI systems. If you look around, you can see a lot of code generation progress happening. You can see some proof generation in the form of AI for math type projects. But spec generation, I would claim, is woefully neglected, and I also claim that regulation might be a killer application for simple spec generation without the other two of these. Obviously, if you have all three together, that's a great product. If you only have spec generation, I think if you can formalize the description of what compliance would look like, then enable companies to be able to generate proofs that their systems are compliant, then you have now sped up compliance, you have made it cheaper, and you have made it faster, because on the regulator side, it's a single click to verify that that proof is valid. In terms of what I'm up to, we are building out the pipeline. We have a write-up that has described what all of these pieces would be that you'd want in terms of tools. We're starting to build that first piece, interagent, which is specification generation. It looks roughly like mapping parts of an informal spec to formal specs. A UX might look like this. If you know people who want to generate formal specifications for business reasons, come talk to me. And the general plan is to do something like this for cyber, but across a bunch of different domains like bio or information or law. There are fun examples of how you could try and formalize what bias looks like for a resume classifier, or what toxicity looks like for a specification language. And I will probably not have time for questions, sorry. Oh, great. Yes.
Okay, how can we help you? What do you need from the community?
I think one of the things, donations are very welcome. Not intended to be a solicitation, but you can find us on Open Collective. Additionally, if you know people who are interested in doing formal verification, who want to experiment with AI-powered tools to do their formal verification jobs, that is interesting. If you know people who are regulators who are expressing compliance or generating standards and are interested in formalizing those, we would like to make sure that the tools that we are building are useful to them. My expectation is that while this is a useful way to generate, while specifications are generally a good way to drive AI safety and have guardrails around unsafe behavior, that this is going to really only take off if we have decentralized and very democratized generation of these specifications.
Could you go back to where you had the two backward loops?
Yep.
Yes, that one. So for the validation, I think that's a user interface issue.
Yep.
And I think that there is a dialogue structure that can help a lot with that, which is essentially the job of the AI in the dialogue is to probe edge cases in what the formal specification would do and check with the human whether those edge cases fall within the human's model of what should be safe.
Yes, I absolutely agree. I think that generation and validation of a specification requires that the human understand the implications of every design decision. And ideally what the spec generation tool is doing is elevating those design questions to the person. I think there are a lot of people saying like, oh, you could generate a spec with a sufficiently aligned AI system. And I think that people who are saying that have never been as part of a debate between a product manager and an engineering manager in which they are both disagreeing strongly about what the right thing to do in a various scenario is. That decision, if you're abdicating that to an aligned AI system, is not something the human would be involved in, whereas here, that is a system that should be raised to the human with implications for either decision.
Mm-hmm. Yeah, and having it be iterative, because the thing the human is most likely to miss is the corner case that falls outside of the model that the human had before he was asked about it.
Yeah, there have been some really interesting conversations we've had around what it would look like to cluster different traces of inputs through the state space of the program and try and do some like naive like unlabeled classification to say like, here are 5 things that this program seems to do generally. Are all of these 5 behaviors intended? And that becomes quickly computationally very intractable, but there's an extent to which that like learned systems can do probabilistic solving of NP problems.
Tomorrow you find out why Mark is so interested in this topic. He's going to give our lunch talk and our lunch discussion on securing civilization. But for now, thank you so much, Evan. That was fantastic. Thanks.
Thank you.